Hi everyone, welcome back to my channel. If you are new here, please consider subscribing, like and leave a comment. In this video, we'll talk about solving this problem z times z conjugate minus 2z plus 2z conjugate is equal to 5 minus 4i. And then we are required to prove that if that's what we have, then the modulus or the magnitude of z is equal to square root of 5. So first of all, let's try to understand what is a genoform, a complex number, or what is a complex number. So what we have on the right hand side, we can see that it has both what we have as the real part and what we have as the imaginary part. I is the imaginary number, and so it represents the part which is not actually the real. So, and therefore, this means that any complex number can be written in the form of a plus bi. This can be the genoform of any complex number because this is the real part and this is the imaginary part. So in this case, what we're going to do is to first of all, we are told that the left hand side is equal to this, and so the idea is that we are going to be collecting like terms and see that if on the right hand side you have the real number, that real number is supposed to be equal to the real number on the left hand side, or we can always group all the real together and the imaginary together and equate each of those parts to 0. Okay, so either way it works. So what you're going to do is to let z equal a plus bi as a general complex number, and then which basically means that the z conjugate, sometimes we use a bar or a star, is the complex number with an interchange of the sign. So this is going to be equal to that. So what does that mean? It means that we can substitute for these two, and then which means we have a plus bi everything into a minus b I minus 2 into a plus bi plus 2 into a minus bi, and this is equal to 5 minus 4i. So let's keep this as short as possible. So what happens is that we are going to open up all the brackets, and then we can try to equate the real and then the imaginary parts together. So when we try to look at this is like a difference of two squares. So I'm going to group that as a squared minus bi, and this is squared, then minus, if you open up, this is going to be 2a minus 2bi plus 2a minus 2bi, and this is equal to 5 minus 4i. So if we open up here, this is b squared and this is I squared, and I forgot to point out that I is equal to the square root of a negative 1. So basically, which means that I squared is equal to negative 1. And so this being I squared, that means it turns out to be a negative 1, and to make this positive, so thereby having a squared plus b squared minus this, and that will cancel, so that will go, and then we'll have this and that reducing to minus 4 bi, and this is equal to 5 minus 4i. So in this case, we can say that this part here is all real and this part is all imaginary because we'll have this. So from this part, you can either group all the reals on one side and the imaginary on one side and remain with the 0, and so you equate the real to 0 and the imaginary to 0, or you can choose to equate the imaginary on this side being equal to the imaginary on this side and the real on this side being equal to the real this side. Either way it works, and so this basically means we have a squared plus b squared, this is equal to 5, and uh, minus 4b is equal to minus 4. And so from here we can see that if you divide by minus 4 minus 4, this implies that b is equal to actually 1. So if we get this and substitute it back here, it means that we have a squared is equal to 5. Take off the 1 squared, which is 1, and then that means a is equal to plus or minus 2 if we take a square root of that. So which means that we have two possible values of a, and so then our z can be equal to, since it is a plus bi, then z is equal to 2 plus b, which is 1, or just I, or we can have z equals minus 2 plus I. So these are the possible values of z, this and this. So these are the possible two values of z. Now, the question wants us to prove that this magnitude or the modulus of z equals square root of 5. And so this means that we are going to have the magnitude of z is equal to the square root of the real part squared plus the imaginary part squared, and so this gives us the magnitude of z. And so magnitude of z is equal to the real part, which is equal to 2. Either way it works because it's going to be squared, so that means we have squared, and then we have the 1 which is here, and so that takes us to square root of 5. Either way, using this or that, it gives us 5, square root of 5. And so this is how we can solve this problem. Thank you so much for watching.